Have you ever wondered if cutting-edge web technologies like Next.js could play a role in designing semiconductors, the very chips powering our modern world? It might sound unconventional, but today, we're diving into how Next.js, a popular React framework, can revolutionize semiconductor design workflows. Semiconductor design is incredibly complex. From crafting intricate circuit layouts to running high-performance simulations, engineers rely on specialized tools like Cadence, Synopsys, and MATLAB. But what if we could build modern, user-friendly interfaces for these workflows? This is where Next.js steps in. Next.js isn't a tool for crunching numbers or running simulations, but it shines when it comes to building dynamic dashboards, data visualization tools, and collaborative platforms. Let's break it down. Imagine an interactive dashboard showing real-time simulation results, performance metrics, or thermal maps of chip layouts. With libraries like d3.js or chart.js, Next.js can turn raw data into stunning, insightful visuals. Need a team collaboration tool? Next.js can power a platform for uploading designs, reviewing files, and annotating issues, all in real time. Or how about a cloud-based design interface? Next.js can provide a seamless front end for managing workflows running on AWS or Azure. What makes Next.js ideal for these use cases? It offers features like static site generation for rendering reports and dashboards faster, server-side rendering for real-time updates, perfect for simulation data API routes, which make it easy to connect with backend tools or cloud services. In short, Next.js bridges the gap between complex semiconductor design tools and accessible modern web interfaces. Of course, there are challenges. Semiconductor design involves massive datasets, so back-end systems must handle the heavy lifting, like simulations and large file processing. Security is another concern. Safeguarding sensitive design data is non-negotiable. But with proper integration and infrastructure, these challenges can be overcome. Now let's look at some real-world possibilities. Interactive tools for reviewing chip layouts or circuit designs right in your browser. Dashboards that visualize simulation results, making it easier for engineers to identify bottlenecks. AI-powered assistants integrated into the UI for automated debugging or design recommendations. And team collaboration platforms for sharing, annotating, and iterating on designs. So is Next.js for semiconductor design possible? Absolutely. While it won't replace the heavy-duty tools that drive this industry, it can transform how engineers interact with data, collaborate, and innovate. What do you think? Can Next.js become the go-to front-end framework for semiconductor tools? Let us know your thoughts in the comments below. If you enjoyed this deep dive, don't forget to like, share, and subscribe to our channel for more insights on cutting-edge tech and engineering workflows. Thanks for watching, and see you next time. Let us